Hi everyone, in this video I'll show you how to utilize DuckDB within Google Colab. DuckDB is an open source relational database management system. DuckDB has no external dependencies. The entire source tree for DuckDB is compiled into two files. This structure simplifies deployment and integration in other build processes. Similar to SQLite, DuckDB is self-contained, meaning it can be run within Google Colab. Other database management systems like MongoDB and Postgres operate using client-server architecture, which requires access to ports. However, Google Colab's environment is managed and restricts access to these ports. DuckDB automatically infers data types. If you read in a table of integers, DuckDB will automatically detect the integer type, and you do not need to explicitly set the data type. DuckDB was built with data science in mind and can work with both Python and R. For example, the DuckDB Python package can run queries directly on pandas data without importing or copying any data. DuckDB can work with a variety of file types and databases through extensions and connections, including CSV files, JSON, Parquet, PostgreSQL, MySQL, and SQLite, to name a few. DuckDB can operate in both persistent mode, where the data is saved to disk, and in-memory mode, where the entire dataset is stored in a machine's memory. If you want to code along, the notebook is available on GitHub and is linked in the description below. As of February 2025, DuckDB is available and pre-installed on Google Colab. We will import DuckDB, and we will also import pandas. Next, we will download the dataset that we will work with. I am going to retrieve the dataset from the UC Irvine Machine Learning repository. This dataset contains data points on individual households' electric power consumption. To download the dataset, I am going to use the CLI. I need to start with an exclamation point, then I will call on wget, and I am going to download the dataset from the specified URL. We can check that we successfully downloaded the data. If I click on the little folder icon, which is for files, we can see that we have our dataset here. It is a zipped file. What I have to do is I have to click the little three buttons and copy the path, and I am going to unzip the data. I am again going to use the CLI. I am going to start with an exclamation point, put in unzip, and then the path to our zipped file. I am going to go back into files, and if I check out my content, we can see that we have our data in a text file. I am going to copy the path. Next, I am going to use the head CLI command to print out the first few rows of our dataset. We can see that we have our column at the top. We have date, time, global active power, and a few more columns. Below our columns, we have the values within rows. Also notice that the data points are separated by a semicolon. This will be important when we need to put in the delimiter when we read our dataset. I am going to create a string called file path, and this will contain the path to our dataset, which is in our text file household power consumption. The first DuckDB database I will create is an in-memory database. DuckDB can operate in in-memory mode. In most clients, this can be activated by passing the special value :memory : as the database file, or omitting the database file argument. In in-memory mode, no data is persisted to the disk. Therefore, all data is lost when the process finishes. I am going to create a variable con1, which will be our DuckDB in-memory database. From the DuckDB module, I am going to call on connect, and I am going to set the database equal to :memory . Now that we have declared our database, I can use con1 to use the command execute, and this will execute a DuckDB command. I am going to create a table called power_consumption, and I am going to get the data by selecting it from the CSV file. I am using string formatting to input the file path, and I am going to call read CSV auto from DuckDB to read in the dataset. I also need to declare the delimiter as a semicolon to correctly read in the data. Now that we have our data read into memory, what I am going to do is run a SQL query on the DuckDB database to retrieve the first row. I am going to save the query into a variable called result, and when I print it out, we can see that we were successfully able to retrieve the first row. Now that I am finished with my in-memory database, I am going to call on con1.close. Since I am done with the database, I don't want it to consume any memory, which is why I will close it. It is also best practice to explicitly close out a database once you are finished working with it. Now that we've created an in-memory database, we will also learn how to create a persistent DuckDB database. To create or open a persistent database, set the path of the database file when creating the connection. For example, in our case, I will set the database equal to household_power_consumption.duckdb. This path can point to an existing database or to a file that does not yet exist, and DuckDB will open or create a database at that location as needed. The file may have an arbitrary extension, but .db or .duckdb are two common choices, with .ddb also used sometimes. For our persistent DuckDB database, I am going to create a new variable, con2. I will call on the duckdb.connect function, and I am going to set the database equal to household_power_consumption.duckdb. And this will create our database file. Similar to our first connection, I am going to run a SQL query using the execute method. I am going to create a table that I am going to name power consumption persist. And I am going to use the read CSV auto from DuckDB to read in our dataset. I am going to run another SQL query like before, where I am going to get the values in the first row of our table. Printing the result, we can see that we were able to successfully retrieve the first row. Now that I am done with the database, I am going to close the connection. Moving on, we will see how DuckDB can work with pandas. DuckDB was designed to work with the pandas module. A DuckDB database can be read into a pandas data frame, and a pandas data frame can also write to a DuckDB database. In this section, I will show you how we can use DuckDB to run a SQL query on a pandas data frame without needing to convert the data frame into a database table. I am going to create a pandas data frame. I will name it pandas_df. I am going to call on the pandas module, and I am going to call on read CSV. I am going to input the path, which is just the name of our text file. I am going to set low memory equal to false. I am going to specify that the delimiter is a semicolon. Finally, I am going to also set the NA values, which are the missing values, as a question mark. Once I create the data frame, I will use the head function to take a look at the first few rows. Now I am going to run an SQL query on the pandas data frame using DuckDB. I am going to take the average or the mean value of the global reactive power column. I'm going to save the output into the variable result, and when we print it out, we can see that we were successfully able to run an SQL query with DuckDB on a pandas data frame without having to convert the data frame into a SQL database. Now we will see how we can read a DuckDB database into a pandas data frame. I am going to create a new connection. This time I will name it con3, and I am going to connect to the database that we created earlier, household_power_consumption.duckdb. Now that we have our connection, I can call on it to execute a query where I am going to select all of the columns and rows from our power consumption persist table. At the end of the query, I can call on the df method, which is going to write our DuckDB table to a pandas data frame. I can call on the head function for our newly created pandas data frame, and we can see that we were successfully able to create the data frame from our DuckDB table. Now that I am done with the connection, I am going to close con3. Now we will see how we can write a pandas data frame to a DuckDB database. I am going to create our fourth and final connection, con4. I will call it duckdb.connect, and I will name the database household_from_pandas.duckdb. Now I am going to create a table from the pandas data frame. I am going to call con4.execute, and I am going to create a table, and I am going to select all of the rows and columns from our pandas data frame. Once our DuckDB database has been written, I can go to Files and check out the content directory to see the actual database files. Our DuckDB database files are listed here. Let us go back to our notebook. Like I've done with our previous DuckDB queries, I am going to run a SQL query to print out the first row within our database. Printing out the result, we can see that we were successfully able to write the pandas data frame to our DuckDB database. Now that I am done with connection 4, I am going to close it out. In the final section, I will show you how you can run statistical queries with DuckDB. DuckDB provides built-in statistical functions that we will go over. DuckDB offers more statistical functions relative to traditional database management systems like Postgres or NoSQL systems such as MongoDB. The first statistical function I will utilize with DuckDB is the skewness function, which is a statistical function that measures the asymmetry of the probability distribution of a dataset. Here I am calculating the skewness of the data within the global active power column. DuckDB has the skewness function built in. Let us compare what it would take to calculate the skewness within Postgres. We can see that this is a manual calculation within Postgres, and it is not as simple as calling a function. Next, I am going to calculate the Pearson correlation between global active power and voltage. We can see that there's a negative correlation between the two. Postgres does have a built-in correlation function, but MongoDB does not. Let us look at what the calculation looks like within MongoDB. The manual calculation for the correlation coefficient between the two variables is pretty cumbersome. The last calculation we'll take a look at is the mean absolute deviation from DuckDB. This statistical measure represents the average absolute difference between each data point and the mean of the dataset. Before we finish the tutorial, I just want to mention that, like every tool, there are upsides and downsides to DuckDB. DuckDB is great to run analytics on smaller local files such as CSVs or Parquet files. However, if you have large amounts of data and your database needs to be scalable, then Postgres is a better option. If you have unstructured or semi-structured datasets, then MongoDB is preferred to DuckDB. Thanks everyone for watching. I hope that this video was helpful. In the notebook, I linked the documentation site to DuckDB if you want to read more about it. I also included a podcast that was really insightful on DuckDB. If you found the video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. I also have a podcast called The Aspiring STEM Geek, which you can check out on YouTube, Spotify, Apple Podcasts, Audible, and iHeartRadio. Thanks everyone for watching and happy coding.